Okay, so now we'll see what are major names and major values. So whenever we are importing data into our Tableau workbook, by default, five fields are created, namely major names, major values, number of records, longitude, and latitude. So we have already seen the significance of number of records. Next, we'll see the significance of major values and major names. So this major values, if we'll place it on the chart over here, right now it's showing nothing. When I'll place major values over here and I change the axis, it shows me all the values which are there in the measures section over here. Means all the fields which are there in the major sections, may it be discount, may it be profit, may it be quantity, may it be sales, all four of these are visible over here. Discount, number of records, profit, quantity, and sales, number of records over here, these five are visible over here. And but these three, latitude, longitude, and major values, they will not be visible. So if we are using major names and major values together, it helps us to identify all the values which are there in the measures. It helps us to show them, and it helps us to see them with their sum. So over here, if I place this major values on the label, I get the sum. That means in my entire data set, means in my entire data source, if I check, the total number of records are these, okay, and the total discount offered, the sum of all the total discount offered is this, the sum of the total profit generated is this, and the sum of the total quantity of products sold is this, and the sum of the total sales is this. So when I plot major names and major values together, it gives me an overview of my entire data set, all the major values in my data set. So all the continuous variables, all the numerical values in my data set, it gives me a summation of each one of them together. Apart from this, major names and major values are also used for showing all the continuous variables, all these major values on a single chart together. I'll show you with this with an example. Let me clear out this thing. So if I wish to see using with respect to order date, these are all the years. With respect to order dates, if I wish to see profit, quantity, and sales, all of them together, I see that all of them are separated in different segments, and I cannot see all of them together on a single graph. So what I can do is, over here, in place of sum, I have this option of dual axis. I can select this. So what I see over here is my profit and my quantity both are replaced on this single graph. The scales are different, but they are depicted on a single graph. They are plotted on a single graph. But if now I would like to add sales also in this graph, that's not possible, because in sales I don't get an option of dual axis. So in such scenarios, this dual axis doesn't works, and we would like all three of them to be together like this. Over here you see sales, quantity, profit, all of them are together. So we want to do something like this, but as of now we don't have an option. So for bringing all three of them together, we will be using major values and major names. I'll tell you how. So I'll remove them all, or basically just let me remove these sum. Let me remove this. So you got my requirement that I wish to plot all three of them together, that is quantity, profit, sales, all three of them together with respect to year, order date. So what I can do is, first of all, I'll like to place major names as the filter over here, and I would like to take only profit, quantity, and sales, because number of records is something I have, and that won't be of significance since I'm trying to plot the relationship between profit, quantity of product sold, and the sales. And discount again will be on a different scale, that is in percentage. So let me take these three together, apply, okay. Now I would be placing my major values over here. You see right now I get this weird chart over here. Now what I'll do is I'll paste major names on the colors. So Now you can see that using measure names and measure values together, I am able to plot all these three continuous values, all these three numerical values, all these three measures, that is profit, quantity and sales on a single scale. So this is possible only when I use measure values and measure names together. Now I think you have been able to understand that what is the significance of these automatically generated fields. If yes, let's move to the next topic. Now let's see the significance of dimensions, measures and discrete versus continuous. So if I come over here in dimensions and measures, if I would like to differentiate the two, all the values in my data set which are textual in nature, those which have text like order ID, customer name, postal codes, product name, all of these fields which are textual in nature, they appear under dimensions automatically when I import the data. And all the values in my data set which are numerical in nature automatically appear under measures, like let it be discount, profit and so on. So by default, our Tableau engine is intelligent enough to differentiate textual and numerical values into dimensions and measures respectively. So all the values which are dimensions in nature, they appear with this blue color. Okay. All the values which are measures in nature, they appear in this green color. Also, when I bring these dimensions on my columns, and when I bring these measures, just let me compare it with say, okay, I'm getting subcategories over here. Okay. And I wish to plot it with respect to sales. So if you see over here, this blue pile, this blue pill, this represents dimensions which are categorical values, and this green pill, it represents measures which are numerical values. Apart from these dimensions, that is these textual values, whenever we drive them over here, they appear in their categories, they appear in their segments which are already there. So this field appears as is, but when I am placing this measure over here, it appears in aggregation, that is it appears in sum. It can be minimum, maximum, there will be some kind of an aggregation over here. Since these are continuous fields, these are not discrete, these are continuous fields, so by default they appear in aggregation. By default it's coming as sum. You can change it as you want, average, median, min, max, the way you want. So whenever you are placing a continuous variable, a continuous measure, a continuous field over here, it will be green in color and it will appear with some aggregation, that is sum, min, max, average, something like that. But whenever you are placing a pill which is discrete in nature, that will or which is like dimension, that will have a color of blue, and that by default will appear in their respective discrete categories which they are. Next we'll see discrete and continuous. So whatever we saw over here, that when we plotted subcategory with sales, we can easily see that a continuous variable which is a measure appears in aggregation, and a discrete variable which is a dimension appears as is, and its various discrete classes are visible over here. Now if we would like to color the chart, then there is a difference when we try to color it using a continuous variable as compared to when we are trying to color it using a discrete variable. So if again I take the example of subcategory, and this time maybe as quantity, then if I would like to arrange them based on some order. Okay, so the highest number of say in terms of quantity, the highest number of sales have been of binders, and the minimum number of quantity sold is of copiers. Now if I would like to color them based on like category, so category is discrete. If I color them using category, they'll appear in different colors. You can see multiple colors over here, and the meaning of each color appears over here. So when apart from subcategory, if I would like to color this with respect to say category, again various kinds of colors will appear. So for each category of the product, a different color has been established. So whenever we are coloring our graphs using a discrete variable, then their color combinations will be multiple. For each category, we'll have, for each class of the discrete value, we'll have a different color. Now, in case we are trying to color it, but not using a discrete variable, but a continuous variable. If I would like to color it using the quantity itself, then based on the quantity, these colors will vary. So I am having the same color, but the lighter the color, the less is the quantity. The higher the color, the more is the quantity. So in case I would like not like to use a continuous variable quantity, I would like to use, say, profit, as to which product gave me how much profit. So over here you can see the product which was giving me minimal profit, that is tables, and the product which giving me maximum profit is something like phones or copiers. So now you understood the difference, that if you are in colors, if you are using a continuous variable, then your colors will be in a palette, like in a definite range, and it will be a continuous variable from negative to, say, positive, and that will be a defined color palette. Whereas in case you are not using a continuous variable, you are using a discrete variable, then you'll have multiple colors over here, like this. Hope this difference is clear to you. Great.